Good afternoon. Thank you all for joining us for the water year update, which is our rainfall and supply levels update. I'm Supervisor Rebecca Hermosillo, Chair of Sonoma County's Board of Supervisors, and also on Sonoma Water's Board of Directors. We're at the midpoint of the year, so this webinar is an opportunity for us to step back and look at where we're at, how much rain we've received, how our reservoirs have responded to that rain, and what that means for our water supply in the months ahead. As you know, Sonoma Water manages a system that delivers naturally filtered Russian River water to communities across Sonoma County and Marin. They also operate flood control facilities that help protect lives and properties. So conditions on any given day, on any given year actually shape how we operate those systems. While conditions can vary a lot, Sonoma Water mitigates some of those variables with a system such as forecast-informed reservoir operations, which is much easier to say, FIRO. FIRO is a collaborative partnership with the U.S. Army Corps of Engineers, with Scripps Institute of Oceanography. I always mess that up. I apologize. NOAA and the California Department of Water Resource, to name just a few of our partners. On average, Lake Mendocino, FIRO helps retain about 11,000 acre feet of additional water per year that otherwise would have been released into that's about like a fourth of Sonoma's average annual water deliveries to its contractors, which is huge. So today's discussion will focus on the Russian River watershed, including Lake Mendocino and Lake Sonoma, and how those reservoirs performed over the last year. And we'll look at what early indicators tell us about this coming season, which is more rain to come this weekend. So today we brought together some partners who play a key role in managing and understanding the system. So we're going to hear from Jeanine Jones with California Department of Water Resource on state trends and forecasting. We're going to hear from Nick Malasavage, Chief of the Operations and Readiness Division for Army Corps of Engineers in San Francisco, and he's going to talk about reservoir levels and FIRO performance. And then we're going to hear from Don Seymour, Deputy Chief Engineer with Sonoma Water, on local conditions and stream flow. So together they will help provide a clearer picture of how water moves through our region, from rainfall to storage and to the supplies our communities depend on. And with that, I'll invite Jeanine Jones to share her slides. And thanks for being here.
Thank you, Madam Chair, and we'll start out with sort of the statewide perspective and how your watershed fits into the big picture. Now, if you look at that animation that you see before you, that's what was going on for us pretty much all of March. The western U.S. was high and dry, and in fact experiencing record heat conditions. And if you look at a map of the entire U.S., you can see just how hot it was for the month of March. The numbers in the little boxes denote rank, as in hottest, for example. Many places in the country in the western U.S. hit their hottest ever temperature for the sustained period of March. And even the eastern part of the country came in just a little bit less than their hottest of record. And in fact, quite a few locations in the West actually hit the April record for hottest, and a few even made it to the May record. So this was actually an extreme heat event, and one that the science community will be having a lot of fun with in the analysis and diagnostics for it. And just to look at California, for us, the warmth really kicked in about the first of the year. and it's unusual to see as much of the state in this bright a red this early in the season. Now, if we go to the entire water year and start talking about water, we're almost exactly average, 99% of average. And what this does, however, demonstrate a good point that while we're average at the moment, California is never average for very long. We actually started out with a very wet water year at the beginning of the season, very, very wet. Some of you probably remember what you experienced then. And we, did well going through, say, the Christmas season. But then as we got later into the spring, things really shut down. And last month, for example, we had record warm and dry. Now we're trending to sort of a last gasp of moisture in April, but our season is wrapping up. Now, if you look at the entire western U.S., you kind of see some of the hints of the wetter season that we had early in the year in those darker blue colors in parts of the San Joaquin Valley. Had I showed you this map in January, California would have been a really blue state. So this is not a surprise in terms of our, uh, um, moving from periods of extreme wetness or dryness to get to average. And if we look at temperature, this is now for the entire water year, we're not quite as dark red anymore because we have started out the season, closer to normal. Normal for us always being warmer than average in the 21st century, but then we were really overwhelmed by the heat at the end of the season. But look at where those red blobs are in the middle of the country. That is the upper Colorado River region. And that area, sorry, trying to make my lights come back on, and that area is one where we're seeing an extreme snowpack deficit, which is important to us in California. Now, if we look at just the snowpack in California, we see that, we had a good start to the frozen season. Then we had a period where nothing much happened. And beginning about the 1st of March, when we had those extreme warm conditions coming on, we went into a very rapid melt period. Now let's look at this a similar diagram, but for the entire Colorado River Basin. The Colorado River Basin is important to California because half of California's population lives within the service area of Metropolitan Water District, which is heavily dependent on the Colorado River, as are other parts of Southern California. The Colorado is hitting its record low of record for snowpack. And although it's too early to call the runoff forecasts yet, will probably be either at or extremely near record low runoff as well. Now, that good wet start to the water season really helped fill our reservoirs. Statewide reservoir storage for most of the state is very good right now. And groundwater basins have had some time to recover. Keep in mind that groundwater always reacts to hydrologic conditions more slowly than does surface water. But because we've had average to wet conditions beginning in 2023, which was a very wet year, we've recovered quite a bit in some of the state's groundwater basins, although the areas of extreme overdraft in the San Joaquin Valley in particular are still struggling. Now, moving on to what's going on now and what do we think is coming ahead of us, you've probably seen a lot of headlines lately, like the one I just grabbed at random and pasted at the top of this slide, saying that, oh, we're going to have a super El Nino, it's going to be really wet, all kinds of things will happen in the coming winter. The graph at the bottom is the official NOAA forecast for ENSO, El Nino Southern Oscillation, which is encompassing El Nino, La Nina, and neutral conditions. So, depending on which month you look at in this forecast, which goes out to end of the year, November, December, January, that's what the NDJ is on the right-hand column. You see that's only about a 25% chance of a super strong El Nino, and overall about a 50% chance, 60% chance maybe for stronger-ish El Nino. So uh, we need to be careful about overstating that, oh, we're going to have a really strong El Nino, because right now, pretty close to even odds for a strong event. And this is only an April forecast. This forecast will change as we go through the season. Now, why do we care about ENSO? Well, the answer is that from a precipitation standpoint, it makes very little difference for California and for the Colorado River Basin. If we look at the North Coast region, where the Russian River watershed is, this is the historical record of El Nino, La Nina, and neutral years, broken down by essentially, um, wet, dry, average sort of uh, uh, visualization. And we see this is a shotgun plot. Not much difference between the different phases of ENSO. And in fact, if you've noticed in the news, some people are saying that we're going to be experiencing the strongest El Nino in 2 decades. They were referring to the Godzilla El Nino of winter 2015-2016. And the graphic at the top shows what happened from the rainfall standpoint. So on the left-hand side, we see the official NOAA forecast, which called for California to be wet. On the right-hand graphic, we see what actually happened. For us, water year 2016 was the fifth year of California's 2012 to 2016 drought. So, an exactly wrong forecast. So the Godzilla El Nino was completely a bust for us in terms of rainfall. And we now know because we have invested in a lot of research since the Weather Service developed this idea that ENSO was a prognosticator for rainfall, that in fact, El Nino or ENSO conditions contribute only about 25% to California's average annual rainfall. Now, this is a graphic that shows the skill of these seasonal forecasts that NOAA and the National Weather Service prepare. And seasonal in this case, meaning if you made a forecast in November, looking out at December, January, February, what's the water conditions, what will they be like? Now, the color shading is an after the fact assessment of the skill of those forecasts over the long term. The white areas on the map show where there was no skill in the NOAA forecast. What color is most of the map? White. The highest skill scores that we see on here are roughly about a 40, and that's on a scale that goes up to 100. So if you were in school and got 40 out of 100 in a test, how would you be doing? Not well. And this is the state of the Weather Service NOAA forecasting capability for longer range precip forecasting. It's a difficult science challenge, but one that hasn't received nearly enough investment at trying to improve these to support water management, which is why we have formed a coalition with a lot of help from Sonoma Water and other water agencies, Western States Water Council, also the California Department of Water Resources, to try and urge Congress and the federal government to do better on these longer range forecasts. And if you're interested in our efforts, take a shot at the QR code on the screen and you will learn more about our activities. Now, wrapping up, what do we think looking ahead for the season? Well, we know because we had this record warm March, which has essentially depleted the snowpack, and that California has been existing in a warming climate for some time. Heat risk is always a thing in the summer for us. 3 years ago now, we had a record summer heat wave in late summer, August, September in California that broke many records for that period of time. And, with this extreme heat, there's always the risk of wildfire. Moving on to fall winter, while ENSO conditions, in particular a stronger El Nino, really aren't diagnostic for us for rainfall, there are other ocean-driven connections that we see with ENSO that are much stronger. In particular, risk of coastal erosion, because a warmer ocean, which is the diagnostic for El Nino conditions, you have higher sea levels and you have bigger waves during winter storms. And also, a warmer ocean off the coast of California suppresses the upwelling that supports the food chain for fisheries and marine mammals. And basically, if you're a seal or a sea lion, a strong El Nino is very bad news for you. Keeping in mind that, for example, in the 2012 to 2016 drought, when I showed that Godzilla El Nino year, that was also a period of record marine heat waves. And for most people, the visible consequence that they might see in the news of the El Nino was all the footage of the poor suffering seals and sea lions. So this is what we can say at this point, looking at the season ahead. But keeping in mind that an April forecast of ENSO is very, very early, and the forecasts aren't really baked in until we're, into, almost early fall. So with that, I will stop sharing and I will introduce Nick, who will talk about the chorus part of this presentation.
Thank you much. So yeah, good afternoon, everybody. Thanks for attending. Just a couple quick slides about our experience through water year 26. On a slide first, plumbing of the Russian River watershed, the two dams, Lake Mendocino, Lake Sonoma. Just want to point out water supply pool, especially as it's at sort of the threshold between Sonoma Water's operational responsibilities and ours at the Corps of Engineers. And then also underscore forecast for reservoir ops again. That 68,400 is, from an operational perspective, is actually 80,000. This is the amount of water that we can hang on to, depending on what we see in the forecast and what that means for flood risk downriver, downstream. Lake Sonoma, similar thing. The 245,000 acre feet is more like operationally 254,500 acre feet. Going to kind of contrast things with this year's experience, but in general, you kind of see the amount of rain we got. Big difference this year, at least from water year to 25 till about this point in 26. Last year we had about 37 inches of rain for the season. This year we only have about 24, so we're about 1 foot less than we did last season. One of the great things about FERO is that we have this thing called pre-release. So in that green box, this is where we see a rather big event. You could see that spike after the green box, but we can take a more measured flood control release to get some water out of the reservoir before the storm, knowing that the storm will bring in quite a bit of storage. See that play out. Afterwards, though, we get above that dotted line. This is where we have to fall back to our rules of we need to restore that flood controller space, or we need to make airspace for the next storm. Walking into that period, we have I'd call small to moderate release, and then a tapering as we get down to that dotted line, knowing that, hey, we're drying out here. We got blue skies. We can just take the foot off the gas and again, store water. Different from last year, we just headed into that dry period. We then had a bigger storm later in the year. We didn't make any pre-releases just because of where we were sitting in time as well as in space in the reservoir. But after that last big storm, we then had to evacuate that space again. Storm over last week didn't produce a whole lot of inflows, but we're from a storage perspective, we're at about 84,000 acre feet. Start of this week. Same date last year, we were at 101,000. So we're at about 15% less total storage than we were this time last year. Stepping over to Lake Sonoma, I guess one more thing about Lake Mendocino is that I showed 3 different types of releases. Back in 2025, we had 4. Now that's only one more, but last year we did have some closely spaced storms where we did a little bit of yo-yoing up and down, and it was just wetter. At Lake Sonoma, same period of time, a reservoir rises with the first handful of storms. It goes above that statute line at 245,000 acre feet. We let the reservoir rise, but then we have that big storm coming in. So we did make a few decisions to stop the pool from rising and actually kind of hang on to it, try and hover there at that dotted line. Big storm hits. Then we wait for, again, that blue sky. We're heading into that dry period. We make a flood control release, and you see how it kind of slopes down, again, trying to make a soft landing back onto what we call our FIRO space. Again, the water that we can hang on to, knowing that we don't see really any rain, but more importantly, any large events, that we are maintaining that obligation for flood protection downstream the life of property. Later on the season, just like at Lake Mendocino, same sort of event, hits the watershed, pops things up, and then you'll see that the steepness of this flood control release, to come back to that dotted line, the inclination is it's less steep, it's more of that step down, and that's just a function of getting later into the season. And we also have the opportunity here, you can see it slopes up the dotted line, to sit on more water. Overall, the differences here, we had 3 flood control releases. We had 5 last year, again, just to more storms of significance, at least how they hit the reservoir and how they were seen as in inflows. Total rain this year, about 34 inches. Last year, 49, pretty close to 50. So again, we're kind of a foot less than we did last year. However, the storage is quite close. Bigger reservoir, different watershed, different numbers to manage that flood control space, largely the same weather. Despite that big difference in rain, our storage is approximately the same as it was last year. From a stage perspective, we're only about a half foot difference in the reservoir and only about 2,000 acre feet. So we're right now 263,000 acre feet. Last year, this time, we were at about 265,000. So tale of 2 reservoirs, very different rainfall, less storage, appreciably less storage at Lake Mendocino exiting this winter season, approximately the same storage at Lake Sonoma. And with that kind of going forward, I want to pass it over to Don.
Well, thank you very much, Nick, and good afternoon, everybody. So as I get going, my slides are going to look surprisingly like Nick's, but Nick was kind of addressing it from a perspective of flood risk management and the FIRO operations. I'm going to be speaking more to the water supply benefit and where we are with water supply this year. And so Nick already showed this slide, gave it, kind of locates the reservoirs, Lake Mendocino, a little bit northeast of the city of Ukiah, and then Lake Sonoma circled there. It's just directly west of Healdsburg. A couple of things I just want to mention is the things that distinguish these 2 reservoirs from each other. First of all, in Nick's slide where he showed that cross-section of the reservoir, and you'll see in my next slide, Lake Mendocino has what's called a variable guide curve. As Nick mentioned, during the winter season, it's at 68,400 acre feet, and through FIRO, they do have the Corps does have the ability to hold on to that some of that water if FIRO procedures are indicating it's safe to do so. But the actual water supply pool where they don't generally dip below is set at that 68.4 number. It does rise in the spring, starting March 1 to 111,000 acre feet on May 10th, and it goes up by about 600 acre feet a day. And so one of those things that's really distinguishing is that Lake Mendocino is incredibly dependent on spring inflow to really maximize the storage in the reservoir. And it's very sensitive to, where we are at the end of the year on that spring inflow. I think the other obvious thing that distinguishes the 2 reservoirs is just the size of Lake Sonoma compared to Lake Mendocino. Total storage, 245,000. As Nick mentioned with FIRO, it's an additional 5% if that water is captured, so 264,000 acre feet. So just a significantly larger reservoir. And then lastly, I just want to mention, although the two watersheds are not drastically different in size, Lake Mendocino watershed is about 105 square miles. Lake Sonoma's watershed slightly larger. I think it's around 120. Lake Sonoma's watershed is just phenomenally more productive than the Lake Mendocino watershed. It's just in a real sweet spot of where storms come in off the Pacific Ocean. And so, for example, we see in general, if a storm event might produce 5,000 acre feet of inflow into Lake Mendocino, we see 10 to 12,000 acre feet at Lake Sonoma. So things that really distinguish those two reservoirs, even though they're both located in the same watershed. So similar to Nick, he showed the cumulative rainfall for this year. I think we're at about, this is the Ukiah gauge. It has a very long historical record, goes back over 100 years. The Ukiah gauge as of Monday was about 28, 29 inches. How does that compare to our, 23, 24, 25, which were very wet water years? Well, like Nick said, over a foot difference. And so seeing, we're about 80% of normal, where all three of those water years, 22, 23, 24, 25, were at or above normal. However, those lower lines show the cumulative precipitation for water year 2020, 21, 22. So we're doing much, much better than that during that severe drought period. So again, you saw this slide from Nick. That is the actual guide curve for the reservoir that separates the water supply pool from the flood control pool. Anytime storage is at or below that line, Sonoma Water is making releases from Lake Mendocino to meet minimum stream flow requirements that are required in our water right permits, and also for uses by downstream users that are authorized to use water that's stored in Lake Mendocino. There's that top of Firo pool that Nick was showing in his slides. That adds during the winter an additional 11,650 acre feet that the Corps now can store at their discretion. The water control manual for this reservoir, Lake Mendocino, was recently updated that formalizes those Firo procedures and that Firo pool at Lake Mendocino going into the future. So again, that solid black line, similar to Nick's figure, shows current storage as of Monday in Lake Mendocino, just over 84,000 acre feet. Without Firo and the Corps' ability to retain that water, that reservoir would currently be below 68,400 acre feet, because we have not seen any we only saw this recent precipitation. March was completely dry. And as you see, that guide curve starts increasing March 1. So if we were held to those old rules in the previous water control manual, we'd be 16,000 acre feet lower in the reservoir. Just as a comparison, this shows water years 2023, 2024, and 2025. As Nick mentioned, we're somewhere between 16 and 18,000 acre feet less than those years. So that's been the difference of, as Nick mentioned, receiving 5 significant atmospheric river events as opposed to 2 or 3. And again, as comparison, that's water year 2020 and 2021 and 22. So we're doing significantly better than those years, but not quite where we were over the last 3 years. Here's the guide curve for Lake Sonoma. It's flat. It's not variable. It's set at 245,000 acre feet. This is that top of the Firo pool, which right now is allowing the Corps at their discretion to store in that pool. That has not yet been done through a water control manual update. That's actually being done, what is referred to a process with the Corps called planned deviations to the water control manual. This deviation was for 3 years. It actually expires in September 30th of this year. We are currently working with the Corps to request a new deviation. This is what we'll be requesting going in the future. It follows the previous deviation up until March 1 exactly, but starting March 1, it continues to rise, making that Firo pool that we're requesting not 19,000 acre feet, but 38,000 acre feet. So here we are with storage in current storage. As Nick mentioned, we're basically right at the top of that Firo pool at almost 264,000 acre feet, just a little below that. And this is what's astonishing. Even though we had significantly less precipitation we're almost exactly where we were those last three years. And that's through those FURO procedures, capturing those winter storms when we can and retaining water when it's safe. And this is, by comparison, this is water year 2020, 21, 22, where we really saw a depletion at Lake Sonoma. Going forward, so Sonoma Water and its water right permits that allows us to store water both in Lake Mendocino, Lake Sonoma, then release that water to use later, has minimum stream flow requirements that we're required to meet both in the Upper Russian River, Dry Creek, and the Lower Russian River. And those minimum stream flow requirements vary by season, but also referred to as water supply condition. And there's 3 water supply conditions for the Russian River: normal, which has the highest minimum stream flow requirements associated with it; dry, which are lower than for normal; and then critical, which are significantly lower. And the water supply condition, that table there represents when the water supply condition is assessed to determine what the minimum stream flow requirements are. So up until January, February, they're assessed once a month. Then starting in March, they're assessed twice a month until June 1st, where that water supply condition and the minimum stream flow requirement is set until October 1. And so since 2023, we have been above that 68,400 acre foot mark on January 1, and we've been above all those thresholds, storage thresholds at Lake Mendocino that set the minimum stream flow requirement, all the way up until April 1 of this year. So for over 3 years, we've had normal water supply conditions. As you see, April 16th, we'll be assessing the minimum stream flow requirements again. That new threshold is 91,000 acre feet, and we're at 84 right now. So we're gonna, with only 1 day to go, we're gonna drop to a dry water supply condition for the first time in several years. What that means is the minimum stream flow requirement on the Upper Russian River is going to drop from 185 CFS down to 75 CFS, and in the Lower Russian River, it'll drop from 125 CFS to 85 CFS. Now, right now, that's not going to have any physical impact to the Russian River because there's so much natural flow still in the system. So, for example, the flow at the Healdsburg gauge is over 750 CFS, and at the Hacienda gauge, it's over 1,200 cubic feet per second. So we're not going to really see impacts to these changing minimum stream flow requirements until we really start to see the watershed dry out and tributary flow in the system recede, and it really becoming dominated by releases from the 2 reservoirs. And so more than likely, we're going to see those conditions as of June 1 also and through the summer. So we're going to have slower minimum stream flows this summer. These are still these flows are still great to recreate at. We have conditions. We'll be working with the fisheries agencies to make sure we're meeting requirements for endangered species when they're moving through the system. And so with that, I'm going to pass it back to Chair Hermosillo. Thank you very much.
Your presentation, and I think that we are going to now, if you have questions, if you could drop them in the chat, and I can help moderate said questions.
Chair Hermosillo, we're going to use the Q&A feature, so let me know if you want to find that. If not, I'm happy to read those for you. Oops, apologies, your sound cut out one more time, Chair.
That would be great. I don't see them.
Great. So our first question was from Fred Albach, and I'm not sure who wants to field this. Is NOAA a reliable player now?
Well, I will start off with a shot at this and then let the others chime in. NOAA wears many hats. It runs the Weather Service, it runs atmospheric research, it runs the marine fisheries program. One of the difficulties that the Weather Service and the research side of NOAA have experienced is chronic lack of funding, not just in the last few years, but over the long term. Some of you probably know that the European weather model outperforms the American NOAA weather model and has for many years, and that's really a function of the lack of funding for research for it. So while NOAA's forecasts at the short term period, say 7-day forecasts, are decent. They're, up on a par with other countries' models, although not quite as good as the European model. When you go to those longer time scales, which are very important for water management, that's where they have really no forecasting skill that's useful, and that's where we really need to see an improvement in the research.
So much. And the next question is, when does California call a drought to conserve reservoir water? I should have been more careful all the time and never revert to business as usual levels of use, but be on a permanent conservation mode. It seems that ag interests want the AU levels of use as much as possible, but deplete reservoir supply if a drought doesn't start. Dawn, do you want to take that one?
Could you repeat the question, Supervisor? Your audio was cutting in and out, and we didn't really hear it.
I apologize. Let's piecemeal the question. The first one is, what does California call a drought to conserve reservoir water?
I could go on for days on that question, but basically, the simplest definition of a drought is when water isn't available for some desired purpose. So, someone who relies only on rainfall with no ability to manage it, such as someone who's doing dryland livestock grazing, if it doesn't rain for a short period of time, they start considering a drought. On the other hand, urban agencies who have reservoirs, storage capabilities, tools for managing water, generally we don't consider a single dry year as a drought, but we look towards multiple dry years. And except for small, very small water systems that have unreliable sources, such as fractured rock groundwater, most water agencies in California are very well equipped to manage a single dry year.
So much. As well, Jeanine, how accurate was the weather forecast from the last time we spoke on this webinar in the fall? And did the weather forecast accurately reflect what we experienced in California and in particular in Sonoma County?
As I said, a weather forecast and weather forecasts are operationally issued as far out as 10 days to 2 weeks. Most of the skill of that forecast is within the first 7 days. And, those forecasts are generally, usable for many purposes. Nick may want to comment on the fact that for FIRO, I believe you're only using the 5-day forecast. But when you go out to those longer time spans, 2 weeks, 3 weeks, 6 weeks, months. That's where the skill is really, it is really only slightly better than predicting average weather conditions. So, what the atmospheric scientists would call predicting climatology. And we just don't have the skill there.
Don, we have a question for you now. The new urban water management plan will be coming out soon, showing water supply conditions up to 2050. Can you provide a brief summary of those findings with Upper Russian River? Will Upper Russian River be constant curtailment?
So I really can't address curtailments because that's not something Sonoma Water has any responsibility over. That's by the Division of Water Rights with the State Water Resources Control Board. But of the findings, the urban water management plan requires water providers to analyze their system for reliability over a 25-year horizon. And one of the main analysis is you have to look at the demands going out in five-year increments and look at how they can be met as they increase for a single very dry year, multiple dry years, and a normal year. And so in the findings of our urban water management plan, which is about to be finalized and taken to our board for approval, indicates that under normal and multiple dry years, both reservoirs have adequate water supply to meet our customers' demands and have carryover storage. For a single dry year, Lake Sonoma has adequate water supply to meet minimum stream flow requirements in Dry Creek and the lower Russian River and our water contractors' demands, and still have adequate carryover. However, Lake Mendocino, under the very severe single-year drought, which in our analysis, Sonoma Water uses the 76-77 drought, the modeling indicates if there's no change in water use and no reduction in demands by Upper Russian River water users, Lake Mendocino could go dry in that situation. However, Sonoma Water is constantly evaluating storage and forecasting out what are the possible what could possibly happen as we go into the future, and we're evaluating different scenarios. If we were to detect that could be a possibility, we would be directly working with the State Water Resources Control Board, Upper Russian River water users on how water use demands could be reduced to preserve that necessary storage in Lake Mendocino to get it through that drought. So urban water management plan does not foresee any curtailments on the Upper Russian River.
Thanks, Don. We have another question from KRCB, which I think might have just been answered. With average or lower than average water supplies this year, do you anticipate asking for higher water conservation from Sonoma County customers? Does that previous answer kind of answers that, or no?
Yeah, I mean, we don't anticipate. We already, Sonoma Water, along with its contractors, has entered into an agreement as the Sonoma Marin Water Saving Partnership a long time ago, and that has been a very successful avenue for water use efficiency. Just not implementing conservation as needed, but implementing water use efficiency programs that are year-round and durable. And as I showed in the presentation, Lake Mendocino is lower than the last 3 years, but Lake Sonoma, which our contractors depend on, is actually at a record high. So no, we don't foresee having to implement any type of additional conservation, what our contractors already do through the Water Saving Partnership.
Thank you. Could the recent AQPI improvements allow us to hold water during events such as the most recent release from Lake Mendocino? Given that the Furo curve rises sharply during that time, it seems we should be able to hold that water if the short-term forecast is dry.
So AQPI is an incredible new tool that's been developed over the last decade, and it's finally has been completed with all the radar sites. However, it does not deliver information on a time scale that the Corps needs to make those release decisions. The Corps starts making those release decisions days ahead of time, not hours. And AQPI works on more like a 6 to 12 hour information for more information that can be used by emergency managers on deploying equipment that could for flooding or sanitary sewer overflows. But I'll pass it to Nick on the timing that's necessary for flood risk management.
You nailed it, Don. One of the things that I was talking about earlier in the pre-release type phase before a storm hits, our plumbing at both lakes has a limit, just like the drain on your bathtub. So we need a certain time horizon that is in the days of lead time to be able to move water out of the lake into the river and safely down the river before a storm hits. So Don is spot on in saying that we're kind of working on days to manage those decisions. And back to what Jeanine had said earlier, the 5-day is very important to us. Typically, for the constraints of our plumbing, we can move the volume of that FERO space in about 2 or 3 days. So a 5-day forecast and the skill in that space is very important to us and very functional. And in that sense, one of the original questions, NOAA continues to be a great partner in that sense, as is Sonoma Water, as is all of our partners. We do continue to be forecast informed, not forecast controlled. And all of this information and the skill that comes from the people who work on this program contributes to the optimization of those decisions.
Great, thank you. Is the Army Corps contemplating amending the FERO curve for Lake Mendocino?
Say no. We did just permanently change it, and that's what we were displaying on the screen. I would say we're not contemplating at Lake Mendocino, at Lake Sonoma. We are actively pursuing changing and making permanent at a future date that FERO curve. I appreciate that Dawn had also noted that we have a deviation in place, and we are pursuing a separate deviation that actually has a greater FERO space as we exit the rainy season. So there's that little bit of evolution that's ongoing right now in the effort to get at Lake Sonoma. But Lake Mendocino did change permanently last October, and we'll sit there for some time.
Thank you. With PG&E likely being granted the variance for the Potter Valley project, do you anticipate that minimum in-stream flows will be reduced to critical levels? And if so, when? And what are those cubic feet per second numbers? And they're also asking if we can repeat the cubic feet per second numbers for normal and for dry.
Yeah, I can take that one. So we have done forecasting, modeling of the system, of the reservoir operations and river flows, and that incorporates PG&E's variance being in place. Even though FERC has not issued an order yet approving it, we assume that it's in place May 1, and we have rules in the modeling that mimic what the variance is. So we do not anticipate dropping down to storage thresholds that would cause minimum stream flows to go to critical level. And as I mentioned, those minimum stream flows are set June 1. So no matter what happens, we would have to take actions with the state board to reduce those minimum stream flows. But no, we don't anticipate that those flows will change. And so the difference between normal minimum stream flow requirements under normal and dry conditions on the upper Russian River are under normal, it's 185 cubic feet per second. Under dry, it's 75 cubic feet per second. And on the lower Russian River, it goes from 125 cubic feet per second down to 85 cubic feet per second.
Okay, thanks. Now we have one more here that's Potter Valley adjacent. Don, maybe you can answer, or we'll see. How does the decommissioning of the Potter Valley project play into or not play into Sonoma water supply? And when ERPA comes into play, how will that increase or decrease Sonoma water supply?
So it doesn't really play into Sonoma Water's water supply in a direct perspective. Sonoma Water makes releases from Lake Mendocino strictly based on meeting minimum stream flow requirements. We never make release decisions based on our diversions down near Forestville. We make releases from Lake Sonoma, the much larger reservoir, based on our demands that we divert for our contractors. And so from a water supply perspective for delivering water, it doesn't play into a huge role. Where it really impacts Sonoma Water is the responsibilities we have for meeting minimum stream flow requirements through our water rights. We also have requirements under the Endangered Species Act of implementing a biological opinion. So it impacts our ability to meet those requirements on the upper Russian River. And Sonoma Water uses the Russian River as this conduit to move water from both reservoirs, but primarily from Lake Sonoma to divert. But we can't just, if we're using that system to convey water and move it around, that whole system has to be in balance. So water from the Eel River has been critical in Sonoma Water's ability to manage the system. And I think if you think back to the slide that both Nick and I showed, that cross section of Lake Mendocino, where it has the variable guide curve that starts increasing on March 1, that means Lake Mendocino, as I mentioned, is very dependent on spring inflow. And so with these the declines in Eel River transfers from the project that have occurred historically in the spring, Lake Mendocino is now much, much more dependent on precipitation events to do that.
Okay, thank you. That is the last question that we have in the Q&A.
Thank you so much. And with that, I just want to thank Jeanine and Nick and Don for sharing your experience, and for everyone attending. The webinar was recorded, so you can go to sonomawater.org to watch the recording. And thank you for attending.